Alright, so we'll look at these interesting questions and we'll just try to do a simple exercise. I would want you and I to identify what methods we'll use to integrate each one of them, and then we'll actually determine the definite integrals one by one, implying that we've got the upper bound and the lower bound. Okay, so let's get into it. Very interesting. A, we need to evaluate the integral of 20 x3 plus 2x minus 4 in respect to x. Okay, so first step is integrate first of all. Okay, so our integral of that is going to be what? So I said for integration, add a 1 to the power, divide by the result. So x to the power 3, if you add a 1 to 3, you're going to get a 4, divide by the 4. Do the same for 2x, it will be 2x squared, divide by the power, which is a 2 now. For the minus 4, it will become minus 4x. Okay, no need of adding the c. Close, put a 2 there, put a 0 on the bottom. Okay, so yeah, this can just clearly divide, right? So that on the next step you don't have to waste a lot of time, just go on and substitute what you need to. So what do you have exactly there? So we have 2, where there's x we'll be putting that first of all, so that will be 2 to the power 4 over 4 plus 2 to the power 2 minus 4 multiplied by 2. Okay, obvious to be subtracted by the substitution of the lower one, which is a 0, and of course obvious will be eliminated because 0 is present. So what do you end up with here? 2 to the power 4, that is going to be 16. 16 over 4, that's going to give us 4 plus 4 minus 8, which all just ends up to 0. 0 minus 0 is just going to be a 0 at the end of the day. Okay, full stop. Done. We'll move to B. What method do you think we should use for B? The integral of 4 to 3x plus 1 to the power 7 dx. How do we integrate this? Alright, so whenever you see something huge like this by itself, just think of U-substitution, right? So yeah, we'll let our U be equivalent whatever is in the bracket. So we'll have integral of 4 to then u to the power 7, and then we have dx there. Now we can't integrate in respect to u when we've got dx there, so we've said let our u be equivalent to what? Whatever is in the brackets, which is 3x plus 1. So we can decide to differentiate that, so that we end up with yeah, derivative of u is just going to be a 3, right? Simple and straightforward. So the moment you do that, you're going to indicate that you've differentiated in respect to x, so dx at the end. If you make dx a subject, you're going to end up with du over 3, right? Divide both sides by that, so you're going to end up with while there's dx, we'll put du over 3. That 3 of course can be put out, so it becomes part of the coefficient, so we'll have 1 over 3, then remain with integral of 4 to u7. We can now just go on and do the needful. This is respect to du. We can integrate that. What's the integral of u to the power 7? So the power will become 8, then we'll divide by the 8. Okay, then yeah, so at that point now we're somewhere close, and we know what to do. So the upper bound is 4, then the bottom 2. So just go on and now substitute. Now we have to be careful because what is our u? 1 over 3. Our u is 3x plus 1 to the power 8 over 8. Okay, then we've got 4 and 2. Yeah, we're done integrating. Now we can just substitute. Okay, which I believe this should be the easiest part for you. Okay, So yeah, that is question B. And so that would be 1 over 3 outside. Substitute your 4. That would be 4 multiplied by 3 plus 1. Okay, raised to the power 8 over 8 minus distributed 2, 3 multiplied by 2 plus 1 over 8. This is all raised to the power 8 again. Okay, so the first one is going to be 13, right? If you check properly in the brackets there, 4 times 3 is 12 plus 1, 13. So 13 to the power 8. Okay, so 13 to the power 8 over 8. Let me write that properly. Thirteen to the power 8 over 8 minus 3 times 2, that's going to be 6 plus 1, 7 to the power 8 over 8. Okay, so this is like that. Okay, now you can just go on and subtract. This is now more dependent on the calculator that you have. I don't want to go into that, but then whatever you get to find is your definite integral. So the key concept here is to understand what these numbers imply and also identifying the method to apply at the stage where you are. Now if you look at C, the integral of cosine 6x sine of x dx, the bounds are pi and 0. Yeah, how do we handle this one? So exactly, look at the one that's big, having a higher power. Okay, so we'll make that be our u, right? So that we can somehow eliminate this one out. So if we let our u be equivalent to the cosine of x, and then you try to differentiate that, we'll call it du. So that is going to be, what's the derivative of cosine of x? That's going to be negative sine of x. And then that will be dx. So our dx becomes du over negative sine of x. Okay, so now we just go on and substitute. Yeah. So for our u, our cosine will become our u, so that will be u to the power 6. Then we'll have sine of x. Okay. Then our dx is du over negative sine of x. Okay. So, and then we know that this and that can just divide. You remain with negative u to the power 6 du. Then to integrate, of course, we need to integrate, right? So to integrate, you know what to do. Increase the power by 1, so we can pull out the negative. Then increase the power by 1, so that would be for power 7. Divide by that same 7. Okay. Then of course we should maintain pi and 0 there. Then you know what is next again. We know that we need to put back our u. So negative our u was cosine of x, right? So our u is cosine of x over 7. So this is the power 7, right? And then yeah, pi and 0, and then we can just substitute now. So now we've got a negative right there. So we've got a negative outside that you can just overlook. Then see what you're going to have. Well, what do we have? We've got pi and 0, right? So what is cosine of pi? cosine pi. So I like drawing the graph. The cosine graph starts from the top part, comes like this. So this is at pi over 2, that is at pi. So it's -1 for the cosine, -1. At 0 it's at, so at 0 it's 1. Okay. So I have negative. Okay. So for the first one, you're going to say that's the cosine of pi to the power 7 over 7 minus cosine of 0 to the power 7 over 7. So we know that for the first one, this is the power -1. -1 to the power 7 is just going to be -1 over 7. Then the other one, that will be positive, so it should just be -1 over 7. Okay. Yeah, and obviously will just be positive at the end of the day because of a negative that is outside. And yeah, if all my computations are good, then we are good to go. So probably have a negative at the outside, and that's going to be -2 over 7 because we've got a common denominator, and so that just gives us 2 over 7 as our final definite integral. All right. Okay. Then for D says the integral of 1, 0, x squared e to the power x dx. I don't want to waste much of your time now. Now that you know all these things already, we already answered this one actually from the previous question. We used integration by parts. You can see it's a product of two different functions, an algebraic function and an exponential function. So you can obviously just take this one to be your u and this part to be your dv. Determine your du, which is going to be 2x, and then your v, the integral of the e to the power x, will just be e to the power x. I mean, you just divide by the derivative of the power. Derivative of x is just a 1, so in this case there's no difference. If we had a 2x there, the derivative would obviously be a 2, and there at least would be a difference. In this case, no difference. We'll go on and substitute. We know that the integral is uv. Our u is e to the power x, and then our v is uv. Our u is x squared, and then our v is e to the power x minus the integral of v du. Our v is that. Our du is 2x. Yeah, we'll just go on and just do it again. So again, this part, apply the same method. You maintain x squared e to the power x minus, this is gonna be your u, that's going to be your dv, implying that your v will still be e to the power x, and then your du will be 2, obviously. So you have to substitute again. Okay, what is your uv? Your u is 2x, your v is e to the power x minus the integral v du. Our v is e to the power x, then our du is 2. Yeah, at this point we're good. So I have x squared e to the power x minus 2x e to the power x. Then that becomes positive. We can pull this 2 out. So positive 2 integral of e to the power x. Again, the integral of e to the power x will just be ex. Remember, divide by the derivative of the power, right? So what remains as our integral is what? So we remain with, if you want, you can put the e to the power x. You'll see that you remain with x squared minus 2x plus 2. Okay, that's what we've remained with. And yeah, want to find now, this is one that is 0, right? That's all we need. And yeah, so for the very first one, we'll just obviously just distribute 1 And if you put 1 in the entire equation, you have e to the power 1 squared minus 2 plus 2 for the first part, minus the other one will be e, and then you have you're substituting 0. You know what happens when you substitute zeros, right? So e to the power 0, of course, is just going to be a 1, and then x to the power 0 to the power 2 will be what? 0 to the power 2 would just be a 0, 0, then plus 2. Okay, so at least that will remain stand out. You remain with e. 1 minus 2 is a negative 1 plus 2, that will just be a 1, minus this part, this is going to be a 1. In the brackets, you're going to have a 2, so 2 times 1, that will be e minus 2. Yeah, we'll just end there. If you've got a calculator, you can punch e and subtract minus 2 to get the exact value. Okay, now for e, are you able to identify the methods to apply? It's also very obvious. It's a product of an algebraic function and the natural log of x. So we obviously know what to do there, right? Integration by parts. Which one is your u, which one is your div? So the priority is given to the logs from Liate. Okay, this helps you choose your u. And then of course the formula becomes uv minus v du. Whatever you start with is your u. So in this case, our u is natural log of x, our x is our dv. So it becomes easy. What is our v and what is our du? So our v, the integral of x is going to be x squared divided by 2, right? And then of course for the derivative of our natural log of x is just going to be what? 1 over x, right? Yeah, then at that point we're headed in the right direction. Okay, so we can now substitute. What is our u? Our u our u is this natural log of x. Our v is x squared over 2, and then minus v du. So our v is x, our du, oh, this is the integral of v du, sorry. So our v is x, and our du is 1 over x. Okay, I don't know how that has come about, but that's exactly what's happening there. The du is 1 over x, our v is x. No, our v is x squared over 2. Sorry for that. I needed to indicate this is dv. This is our u. Our v is that. Okay, sorry for that. I apologize. Then, yeah, we'll just go into it. Then natural log of x. So this will just be x squared over 2, natural log of x. Then minus the x will cancel out. So remain with integral of 1x and then over a 2 there. You know what to do there. Okay, so you can pull out the fraction, or you can just go on and integrate directly. Doesn't really matter. So if you go on and just do it directly, you obviously have x squared over 2 natural log of x, and then you pull out the fraction to be minus half. Then you remain with integral of x, which will just be x squared over 2. Okay, obviously on the next step it's obvious you have x squared over 2 natural log of x, then minus x squared over 4. Yeah, that's what we have at that point. Very interesting, right? Then you can now substitute in what you need to. Okay, so you've got x squared natural log of x minus x squared over 4. Then you've got 8 and 1. Okay, So if you substitute 8, you have 8 squared over 2 natural log of 8 minus 8 squared over 4 for the first part, and then minus the case where you substitute in your 1. So if you substitute in your 1, what do you have? You have 1 squared over 2 natural log of 1 minus 1 over 4. Okay. So what you end up with is you have 32 natural log of 8 and then minus 8 squared. That's going to be, what's 8 squared? 64. 64 divided by 4, that's going to be 16, minus natural log of 1 is going to be a 0, right? So 0 times half is 0. You just remain with 0 minus 1 over 4. So you remain with 32 natural log of 8 minus 16 plus 1 over 4 m. So just remain with 32 natural log of 8, negative 16 multiplied by 4, that's going to be negative 64 plus 1, negative 63 over 4. Yeah, that's enough to remain with. Okay. Of course, if you want, you can just do away with natural log of 8 to the power 3, but this is okay for me. Alright. So yeah, that's pretty much how you handle E. For F, nothing complicated as well. F is just having sine 3, yeah, sine to the power 3 of x. So you obviously want to just do something interesting there. Okay, so what happens if we say the natural log of the integral, integral of that, this is 8 sine, this is sine cubed of x dx. What method do you think we should use here? So this is a big power, only a single function, so obviously it's supposed to be U-substitution. Now if you just do direct U-substitution there, this is going to give us issues because how are we going to do away with the dx there? So we can do something strange. We know that sine cubed can be expressed as a product of sine of x and sine squared of x. Okay, so that at least when we make our u to be equal to sine of x, we can come and cancel out one of these, yeah, and we'll do some miracles here and there. We know that sine squared of x is the product, or if we go to our identity, is the same as 1 minus cosine squared of x, coming from the most basic identity, from the addition of sine squared of x and cosine squared of x. Okay, that is where this is coming from. If you make sine squared of x the subject of the formula. Okay, so we have our integral 8, and then we have sine of x, and then sine squared of x, which is the same as 1 minus cosine squared of x. Then yeah, for our dx, du becomes, derivative of sine of x is what? No, so we don't have to make it that because you give us cosine. So instead we can say let our u be equal to cosine of x, so that when we differentiate that, it's going to give us negative sine of x, so that it can cancel out that. So if you make dx a subject of a formula, you're going to have du over negative sine of x. Okay, good. This and that can go. Can put the negative 8, remaining with that. Okay, so what do you have remaining? You have your 8. In the brackets you have 1 minus, where there is a cosine, we'll put our u squared, and then du. At this point, at this stage, we now have the capacity of the authority to go on and now integrate, since we now understand the point where we are. Okay, so how does integration look like here? How does integration look like? So when you do just distribute the, in fact, we just leave it. Where has this 8 come from again? I already put it out. Okay, so for our integration, what's the integral of 1? So I have minus 8 outside. Where did the negative even come from? Where did the negative come from? I want to see where I got the negative from. But anyway, let me undo some things here. We see. Okay, it came from the bottom there. Alright, so we are now sure of a negative. So on our next step now, what we're saying there is this is not there. So the integral of 1 is going to be u divided by the 1. Integral of u squared is going to become to the power 3 divided by the 3. Okay, we've got a negative 8 outside. Then we just add the bounds, so pi over 3 and 0. And that's all we have there. So negative 8. Then for our u, we can put back now what we had, cosine of x minus cosine cubed of x over 3, then pi over 3, and your 0 there. So now I just want you to now just substitute normally as you would to deal with f. Okay, so you've got pi over 3 and you've got 0 there. Okay, so for your own information, what is cosine pi over 3? Cosine pi over 3 is the same as cosine 60, which is just half. Then this is just cosine of 0, which is just a 1. So in short, you have negative 8. For the first part, that's going to be half. So half minus half cubed, okay, multiplied by 3, and then minus, for the 0, that's going to be cosine of 0 is going to be a 1. So 1 minus 1 to the power 3, like that. Okay. So what's the difference between the two? Is our goal. Okay. So you now know where to take your answer. You now know what to do with your answer. So that's going to be probably something like 2 over 3 minus 11 over 24. Yeah, but at least I've shown you how to navigate through, and I believe that from this point it shouldn't be so complicated for you. Then for G, what method do you think is suitable for us to handle G? So these are all trig functions. You can't use integration by parts, so we just have to use the U-substitution. And how best can we use best use the U-substitution? So you look for one that is like having a greater power, that is sine, right? So let our u be equal to sine of x. Then yeah, integral of pi over 6, 0 sine 6x cosine 3x dx. If you are to differentiate that, you're going to have cosine of x dx. So you see that dx will be willing to do something, right? So you have dx being equal to du over cosine of x. So the cosine of x there, one of them can disappear, right? So pi over 6, 0, where there's sine, we'll see u to the power 6 now. And then we've got cosine 3x, then du over cosine of x at the point where we had dx. Then part of this will just cancel out, you remain with cosine square of x, right? So we have integral of pi over 6, 0. We've got u to the power 6. Now this can be expressed as a difference of 1 minus sine squared of x, okay, du. Now where there's sine, we've said we can put our u, so it'll be u squared right there, okay. So that on this next step, you can just confidently just, substitute. So we've got pi over 6, 0, and then you have u to the power 6 minus u to the power 8 now. That's now du, right? So yeah, we just move to the next step now and just do a normal integration. How do we integrate? We increase the power by 1, divide by the result. So that will be u to the power 7 divided by 7, u to the power 9 divided by 9, and yeah, we have pi over 6 and our 0 there. So pi over 6 is practically 30, so the question is, what is sine 30? Sine 30 is just half, right? What is sine 0? That is just a 0. So you even know now what will happen to our answers. I've already given you ideas, okay? So practically it will just be like, you just substitute on 1. Whenever you've got this sine 0 there, it's just 0, so just focus on the first one. That would be 0.5 to the power 7 over 7 minus 0.5 to the power 9 over 9, yeah, minus 0. So that would be your operations for G. Then just want to add a few things to H. What do you think? I think we've answered this question before. Integral of 2, 0, 4x plus 8. This is also just a similar function. And you just look at the radical. Whatever is under there, make it your u, right? And then you just differentiate that. Your du just becomes 2x plus 4 dx, and you know what to do. While there's dx there, you just substitute the necessary, right? So that's going to be du over 2x plus 4. Now your 2x plus 4 can be divided twice into the other part. Okay, so you have the integral of 2, 0 there, because remember you can just pull out a 2, so that you have 2x plus 4. Okay, then that 2x plus 4 can just come and cancel out with this. Then under the square root you've got your u there, and then you've got your du remaining there. So this and this will just divide, right? Then you remain with the integral of 2, 0. You can pull out the 2 that has remained, and then you remain with integral of u du. Yeah. So you know what to do at that point. This is just going to be u to the power half, and you've got a 2 there, du. So what do? So you just increase the power by 1, which will probably give us 3 over 2, right? That's what I believe. U to the power half is just going to be 1 over 2, and 1 over 2 plus 1 divided by the result, which is of course just going to be 3 over 2. So 3 over 2, and dividing by 3 over 2, I prefer multiplying by 2 over 3, the reciprocal of it. Multiply by 2 over 3. Then don't forget that we had our 2 there outside. Okay, this is all raised to the power, this is all going to be 2 and 0 as our bounds, and then yeah, just have our 2 there. We've got 2 and 2 over 3. Yeah, so 2 over 3, and then your u is to the power 3 over 2. Yeah, 2 and 0. You just substitute. You can put the constants outside. So that you have 4 over 3. Then you have u. Your u now is x squared plus 4x plus 1 raised to the power 3 over 2. Okay, then 2 and 0. So you can just plug in the 2 for the first part. So 2 to the power 2, obviously that's going to be a 4 plus 2 times 4 is going to be 8 plus 4, 12, 13. So you know that you're just going to remain with 4 over 3 multiplied by 13 raised to the power 3 over 2 minus the other one. If you substitute a 0 there, 0, 0, you just remain with the 1. And yeah, should be able to simplify from that point, and yeah, then you're good to go. So let me teach you a bit of some of these things, right? So what's going to happen is, when I say 13 to the power 3 over 2, the implication there is 3 over 2. The implication there is I can make these 2 can become the square root, then the 3 would become the power of yeah, so that would become the square root of 13, then to the power 3 multiplied by 4 over 3, and then minus a 1 right there. So at that point, at least you know what to do. Okay, so come up with a common denominator and do what is necessary. Alright, so at this point we can just actually distribute the 4 over 3. So that you have 4 over 3 for the first part with our 13 root of that, the power 3, then minus again 4 over 3 when you distribute it to the minus 1 there. And clearly we have a common denominator of the 3. So just draw one line and put the 3 on the bottom. Okay, then yeah, something like that. So pretty much that's where we end for this solving, and yeah, let's proceed to the next question.